Metricon 2010 Prism coupler. This is the main system is here with all the three lasers inside it, and the Prism coupler interface module here, and the personal computer and the monitor system. The system application is a DOS based application. So here, by clicking on the icon, I'm able to run the application. This is the configuration screen that popped up, and in this screen we can change the parameters. So various parameters such as the storage file name could be changed time to time, and here it assumes that we are using a silicon substrate. The Prism code is here. Usually the Prism code is written on the Prism. So if there is a Prism like this, the code will be written on the top, and the Prism can be inverted, and there will be a second code to be entered. So these numbers are very critical for the measurements. For accurate measurements, the code should be entered correctly. So basically the Prism is to be mounted vertically like this, and a thumb screw will secure it in its position. So anytime a Prism code is entered, there will be the scan range data to be entered, scan start, scan stop. These are the numbers that could be adjusted. So start will be always a positive number, and the scan stop will be a negative number. And the next parameter that is to be entered is the wavelength. So it depends on what wavelength is in use, and the wavelength selection is to be done using these stoppers here, these knobs, by rotating them to off position, so you are disabling it, and by rotating it to on position, you are enabling the wavelength. So at any point of time, only one wavelength should be enabled, and the same number is to be entered on the screen. So currently it is set for 50 nanometer wavelength. And then we have the Prism index numbers. These data are the factory set. It could be changed if desired. And the print format has three options, and in order to print or save the results and intensity plot, we have to select print format option 3. Also, disk save format also could be changed in order to save the print. Likewise, you select like 3, you can select both, or you can only save the results only by selecting option 2. So usually the results are recorded in ASCII mode, and there are other options available here. We can use a sort key, and we can enable at least 3 keys for desired options. Now, there are other configurations. There's one more configuration screen that can be accessed by typing in access. And in this screen, certain mode parameters can be selected, number of modes to use, and the scan speed can be adjusted. then wavelength index numbers. So you can select any one of the three options available. And the rest of the parameters can be adjusted, such as so the wavelength index number 3 I'm selecting because currently it is 1554. So once all the parameters are entered, escape key will bring back to the previous screen, and again escape will take you back to the So in this mode, once the data is entered, we have to do the referencing. So the unit will find the angle of the laser. So here we press F1 for auto referencing. At any point of time during the measurements or after the measurements, in order to switch back to the reference measurement, press Home key on the keyboard and it will take you to the screen. So during the referencing, the table will turn all the way to the limit switch, which is the limit switch is over there. So the system will hit the limit switch. Talking about that limit switch, and it will proceed to do the reference measurement. I want to demonstrate how you can reference it again. So Home, and then press F1. So after the table referencing is done, the system will prompt to enter sample ID. So the referencing is indicated by two peaks on the intensity plot, and if it is successful, find the reference. And once it is done, press any key to continue, and then here we can enter a sample IDs, and then you press, once you're entered with sample ID, then on this measurement screen we can enter a desired number of modes if necessary. Right now I want to do a substrate refractive index measurement, so I have to press F9. So various options exist here. By pressing F2 we can see various help menus available, and press escape key to go back to the same screen. F1 will assist to go to auto mode. At any point of time during measurement, pressing escape key will abort the measurement. And the dual films option can be selected by F3. And there are options for to enter a offset or skip a mode, or a step to step to the next mode. And then the clear data is to clear the data if at all the desired data is not achieved. And then change plot is to change the beginning and the end of the scan, that is the start and stop. So I'm going to enter 300 for the beginning and enter negative 2900 for the end of the scan, and the plot will be replotted. So I'll select F9 for substrate. So F10 is for PC, is for Prism coupler film thickness measurements, and the substrate index measurements, and L is for the waveguide loss measurements. So by selecting F10 like this, we can switch between the modes. So you press F10 and then switch to loss measurement. If you say yes, then it will switch to loss measurement. If you say no, it will stay back. And then also F11 option exists for transverse electric and TM mode and TE mode options. So I'm going to start a substrate refractive index measurement. So after the scan, the unit located the knee point at plus 74. So in this scan, we see the beginning and end of the scan angle and the intensity on the y-axis, and the cursor location, the position versus the beta, which is the refractive index. So any plot could be interpreted in a different ways. So that's where the refractive index measurement took place. And right now the printer is working. It's a slow printer, so sufficient time should be given before going for the next measurement. The printer is attached to the PC on the line printer port. So now I'm going to switch to the next wavelength and demonstrate how it goes. So I'm going to turn the knob 1550 off and 1300 nanometer on. And there's a manual slide inside. In order to get the 1300 nanometer laser in line, the slide has to be pushed in. For 1550, the slide has to be pulled out like that, and it has to be pushed in for 30 nanometer. And there is a manual attenuator here for the laser. If a brand new laser intensity could be high, so at that time this has to be rotated to normalize the signal. So I changed the wavelength, so I don't know, go back to the setup and go to the wavelength and change it to 1316. And also I had to go back to the second screen and enter wavelength index number. So I'm going to, since we changed the wavelength, we have to do the reference measurement again. So So I'm going to do the auto referencing. So we are now using 1300 nanometer wavelength for referencing. So there is a pneumatic switch on the left hand side of the unit. This pneumatic switch actually helps the sample to be held against the prism pneumatically using this cylinder here. Now the pressure of on the cylinder can be adjusted using this regulator, and the gauge also gives the indication of the pressure, which should be about 35 to 40 psi. Now the new wavelength reference is located. So once it is located, you can enter the sample ID test 2. I'm also going to change the plot. So I'll enter 300 and negative 3000. So there are offset and gain knobs on this Prism coupler control module, and there is a table rotation knob here. This rotation knob can be used when manually the peaks are to be located, and the gain can be adjusted in order to bring the intensity plot within the scale, so it cannot go above the scale. So gain and offset should be adjusted. So my gain was too high, or the offset was off, so I'm going to replot it. So the change plot button is only to replot the desired range. So if we want to limit the scan, we have to enter it in the configuration screen. The start scan, we have to enter it as 300. So I'm using a simple glass substrate with refractive index about 1.5. So this is the second wavelength measurement. So it has located the knee for the second wavelength, and the substrate index is about 1.49642. So I'm going to switch it to the helium neon laser now, and so since we changed the wavelength, now we have to again do the referencing. So these were the previous plots. I ran the sample several times. It's a thermal paper, and right now it is printing the recent measurement scan. So the substrate index value is measured, and now I'm going to switch it to the third wavelength, that's 633 nanometers. So I have to change the setting here, 622.8 nanometers. We enter to enter the data. We'll be referencing quickly. So I have a silicon dioxide film on a substrate. The film thickness is about 9,400 angstroms. So this is silicon dioxide on silicon. I'm going to test this sample shortly after this refractive index measurement using the third wavelength, that is the helium neon laser. The diode laser, the IR laser power supplies are inside the cover here, and the helium neon laser power supply is attached to the casing on the back side of the unit. So now we have referenced it, and then we're going to enter the sample ID, and now I'm going to do the substrate refractive index measurement again. So I was adjusting the offset while it was doing, I don't know. So this is the plot, and there is the knee point. Hopefully they will compute the refractive index. So that one demonstrates that the third laser, which is the helium neon laser, also works to measure the substrate refractive index. So I'm going to, while it is printing, I'm going to change the substrate. So I'm going to first turn on the pneumatic switch off position, and the plunger is out, and my sample is out. So this was the glass sample I was using. So now I'm going to switch it to the second sample. I have silicon dioxide on silicon. So we have to position it near the prism and then turn on the pneumatic switch. So once it is held, the prism coupling is very critical for the measurements here. The location of the beam, the alignment of the beam, and the gain and offset plots, and also the coupling is dependent on how clean the prism is and the substrate is. So measurements are better achieved in a clean room environment. So I changed the sample. Now once the print ends, we can do the second measure. So manually I can rotate this knob to the right, and right now it's I'm manually plotting it. So the gain is too much, so I can reduce the gain. I'm just demonstrating manually how we can plot it. So once the satisfactory plot is achieved, which is not above the maximum scale here or below the 0 scale here, I'm going to do the automatic measurement because we measure and compute. So we are still doing the substrate refractive index measurement here. But this is actually now in this plot it's going to measure the film refractive index because it's not a transparent, it's a transparent film over there on a substrate. So for some reason the first knee is not found, so we have to slightly fine tune it. So assuming the knee is located by pressing the left key, so that's the refractive index measurement. So the fine tuning of the parameters is desired to achieve this. So I'm now going to switch to the film thickness measurement because we are having a nice mode pattern here. So I'm going to change the data storage file name as 1706 DTA because the previous data storage file got filled up. So I'm just entering this, and hopefully we'll be able to take a measurement. All the cables connected to the main system, the interface box and PC will be labeled and marked, and all the cables will be disconnected for shipping. And the green ground cord should be properly connected for the system functioning properly. And in case if the signal is lost or anything, first make sure the connectors are firmly connected. So now the reference peak is located. I'm just going to enter test 4 and then do an automatic measurement. So this time I'm not measuring the substrate refractive index or film refractive index. I'm just measuring the film thickness on it. So at least 2 modes, if they are detected, the thickness can be measured. So in this scan, I'm able to see 3 modes detected, and the software will automatically compute the data and give the thickness measurement in angstroms. So the thickness value tallies with the measurement. made, and it is 9,460 angstroms. So now I'm going to show that the waveguide loss measurement option works. So I'm going to select F10. So first let me remove the sample here. And then if I select F10 and it says switch to loss measurement, I want to show here, and I enter Y and then F1. You can see the detector starts to move, and I'm not going to allow it to go because for the fiber or waveguide loss measurements, proper assemblies ought to be mounted here. So I'm going to switch it back to the Prism coupler and say yes. Switch to Prism coupler, and then once I say so, does the loss measurement detector need to be moved? We say yes, so the detector will go out of the way. So I'm going to reload my sample just to do the thickness measurement. I don't have a sample to do the waveguide loss measurements, so we assume that this unit is capable of measuring the waveguide loss measurements. The user must record the micrometer positions for both of them here. In order to align the prism, anytime a new prism is used, it may be necessary to move these to align the laser to locate the beam at the proper coupling point. And once it is achieved, these numbers should be recorded. I'm going to show how to remove the prism right now. I'm going to turn off the laser for safety. This thumb screw, the top thumb screw, has to be removed, and then once you remove it, you can rotate it like that and take it out. So the power switches for the lasers, the infrared lasers, are on the modules. You can turn it off. And it's a used prism, but it works. So this is how we load the prism again and secure it using the thumb screw. So it is always safe to remove the sample when the unit is not being used. A hard copy or a manual on a DVD or CD will be included with the machine, which will have all the chapters, how to operate the machine and how to diagnose the problems and how to change the lasers as well. So the lasers in this machine are consumables, and right now they appear to be working, and they are not covered under warranty.